Okay, right back into it then. So we're back in our simulation here where we see the source busily emitting waves and the observer detecting these waves. And you can see the waves from the source up here and the waves from the observer right here. So as promised, the Doppler effect, which I want to talk about now, has to do with what happens when I pick up the source and shove it towards the observer. So what I want you to watch very carefully is a couple things. I'll run through it a couple times, but here's a couple things to watch. As I drag this source towards the observer, try to see how the frequency or how frequently the observer gets hit by one of these gray lines that are coming out. So if I slow it down a bit, what you want to do here is keep your eye on these gray lines here, sort of the spacing between them. So bang, 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 bang. Okay, see sort of that rate in there? Bang, bang, that rate in there. When I pick up the source and shove it towards the observer, see if you see anything interesting about the bang. So here we go. 3, 2, 1. Here we go towards. Look at the bang, bang, bang. Now it's bang, 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 bang. See how it's gotten faster? The bangs sort of have increased in their frequency, right? So as the source moves towards the observer, it looks like the bangs get a little more frequent. Remember, I went from bang. I went from bang, bang, bang to, let's see if we can do it again. Bang, 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 bang. See, it gets a little faster as we do it that way. And that's the key first principle from the Doppler effect. And let me let you watch one more, then I'll summarize for you here. So hopefully you saw that these waves, the so-called wave fronts, hit the observer more frequently when I'm moving towards the observer. Now look up here for the waves detected by the observer. And I'm just going to do that the same thing again. I'm going to push the source towards the observer. So watch up there. What happens, you can see right here in this region where I was pushing the source towards the observer, you see the observer detected these waves at a higher frequency. So there's the bang, 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 bang as we stopped again. So hopefully you see that first effect, and that's the first thing I'd like to tell you about the Doppler effect. So that's the first thing. The Doppler effect in principle is all about motion of the source, okay? And the first thing we noticed in that motion of the source is that when the source moves toward the observer, let's say the frequency of the waves go up. And the way we're discussing frequency, or at least hearing it, is me calling out the word bang every time one of those waves hit the observer. So I hope you saw that. As the source moved towards the observer, the frequency of my bangs went up. I went from bang, 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 to bang, 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 like that. That's the first premise of the Doppler effect. And I bet you can guess the next one. The next one let's just leave these together like this. The source and the observer right next to each other. The source is still busily emitting its waves, no problem. You see the waves detected by the observer here and the waves emitted by the source. Now what I'm going to do is I'm going to drag the source away from the observer like this, away. So what do you see about the bangs now? So bang, 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 bang. Seems like they're slower. Look at the wavelength up here, how spread out it is. It's like bang, 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 bang. Then when the waves resume, normally we're back to the sort of the bang, 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 bang like that, just in the normal case. So I hope you can see that. And let me run it one more time, because I can speed this up a bit here. Maybe move the source over here a bit more. Okay, one more time. Let me drag the source away from the observer. And I hope you see that the observer sees the waves arriving less frequently now. The spacing is bigger between those lines hitting the observer. And that's your next and final conclusion about the Doppler effect. It is about motion once again. And the second thing that we saw here, number 2, was when the source moves away from the observer, the frequency goes down. Again, the banging sound moves down. Those are the 2 and only facts you need to know about the Doppler effect in order to understand where Mercury's rotation was discovered. So now that I have it running nice and fast, let me just run it one more time. So this is where the source is stationary. There is no Doppler effect. But as I push the source toward the observer like this, you can see the waves all bunch up in front of the source, and they go like almost like as they hit the observer very fast, and they go back the other way. Look at the observer again. The O, doom, doom, bang, 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 very slow. So toward, you see the waves bunch up, and away they get all laggy again. This is pretty fun here. So you can totally change the frequency received by the observer by just moving the source either towards for higher frequencies or away for lower frequencies. This is kind of fun. All right, and a quick wrap up here. One more fact about the Doppler effect is that I guess number 3 here, as we'll call it, is the amount of the frequency change, or I guess in Doppler lingo you can call it the frequency shift, but it's really the change or shift, whichever. The amount of the frequency change or shift is related to the speed of the source. Okay, so I only had control over one speed in the simulation, but if the speed went faster or slower, the frequency shift would get larger. So loosely speaking, let's just say the delta F, which is the frequency shift, let's just say that's kind of proportional to the speed. So the faster you go, the higher the frequency shift. So if you keep these 3 things in mind, then you'll be ready now to discuss how Mercury's slow rotation was discovered.